Alrighty. Using the unit circle to find trigonometric values. Here is a blank unit circle. And here's where we're going with this. I have, bam, how do you use the unit circle to find sine values? So I'm going to find these three sine values. Sine, you should know, is opposite over hypotenuse. So do you see I have three triangles here? These are special right triangles, and watch what happens. If I take this special right triangle and stick it right there on a unit circle, you see the 30 degrees. And if I'm saying sine of that 30-degree angle, I want opposite over hypotenuse. So isn't the opposite 1/2, and the hypotenuse, if a radius 1, is 1. So what is 1/2 over 1? That would give you sine 30. Now, real quick, why is this coordinate here in the corner? Why do I have this coordinate? We'll come back. Let's talk about that. The coordinate comes from, well, isn't this saying, to get this coordinate right here, isn't this saying I went over square root 3 over 2 and up 1/2? Isn't that the coordinate saying? X, y. Over x, up y. That's the coordinate. Now, like we said earlier, what is sine 30 degrees? Sine 30 degrees is going to be opposite over hypotenuse. Hypotenuse 1, which is 1/2. So if I want to find sine 30, could you just look at the coordinate on this? Can the coordinate tell you the answer? That's what's going to be happening here. Watch what happens. We're going to do a 45, 45, 90 triangle. Are you okay? Those are the sides of a 45, 45, radius 1, or hypotenuse 1. So what is the coordinate right here? Can you see the coordinate? Can you tell your coordinate is, bam, just the x and the y. So there's my coordinate. Can I use that coordinate to find sine 45 degrees? Well, isn't sine 45 degree going to be opposite over hypotenuse again? So isn't it just going to be that value right there? Which is both the same. Boom. These coordinates are telling us the answers to sine values. Now, why do I have a y right here? Have you caught on that sine, has it always been the y value? Isn't it going to be the opposite, which is the y value over 1? That's important. That's why that y is right there. So, look at this one. Pi over 3. Isn't that 60 degrees? Don't we have a 60-degree right triangle now? Isn't pi over 3 the same as 60 degrees? So if I want to find sine pi over 3, can you quickly look at this? Put the coordinate. And by shortcut, isn't it just the y value of the coordinate? Isn't it just going to be that y value right there? Isn't it going to be the opposite over 1 hypotenuse? So the shortcut for sines is to just look at this coordinate, and it's the y value. It's the opposite over 1. And that is what's powerful about these coordinates. These coordinates give you answers to trigonometric values, degrees and radians. You can be radians or degrees, and they give you values. All right, so let's do it for cosine theta. Cosine is adjacent over hypotenuse. So if I stick on, for cosine, if I stick that right there, 30 degrees. All right, and I look at my coordinate, see my coordinate? Isn't cosine going to be adjacent over hypotenuse? And what do you know about adjacent? Isn't adjacent your x value of the coordinate? Adjacent is your x. Adjacent is your x, opposite is your y. And wasn't opposite sine? So adjacent is your cosine. Do you see why it says x there? So if I want cosine 30 degrees, isn't it just asking for that value right there? Bam. I found it without doing any math. You just look at a picture. So can you find cosine pi over 4? Are you okay? Pi over 4 is right here. So So pi over 4 is right there. So can I find the coordinate? Is there my coordinate right there? 45, 45, 90. And I want the x value. I want the adjacent to 45. So isn't it going to be square root 2 over 2? I want cosine 60 degrees. Okay, let's do the 60. There's the 60. So, okay, there's the coordinate. What's the answer to cosine 60 degrees? Is it the x or the y? It's the x, the adjacent side. And bam, you quickly have quick answers. The unit circle, these coordinates of the unit circle are quick answers to sine and cosine problems. It's kind of cool. All right, let's do tangent. Tangent. Tangent is opposite over adjacent. All right, so let's do tangent 30 degrees. See my 30 degrees? Opposite over adjacent. Ooh, that's an uglier fraction. Opposite over adjacent. Alrighty, let's do this, okay? So there's my coordinate. Isn't it going to be the y value over the x value? The y over the x. Isn't that like rise over run? Y over x. Rise over run. Now that does some math here. To get the answer, my answer is square root 3 over 3. How the heck did I get that answer? Well, what I did is I took 1/2 and I divided by square root 3 over 2. I did the y over the x. And when I do my math for that, that becomes 1/2 times 2 over the square root of 3. Those reduce to 1 over square root 3. Now you might say, that is not the same number. It can be simplified. To simplify this, we now multiply top and bottom by the square root of 3, which leaves us with the square root of 3 on top. And what's the square root of 3 times the square root of 3? It's the square root of 9. Isn't the square root of 9 3? Now, you might say, that sucks. Every tangent, I got to sit there and divide every time. No. Over time, if you do it enough, can you just memorize this answer? Over time, can you memorize, well, whenever I have this fraction divided, can I memorize that's my answer going to pop up? With practice, you just sort of start memorizing this. It's not something that you have to calculate over and over again. The only reason you do is if you forget it. You're going to recognize that when I say tangent 30 degrees, it's square root 3 over 3. That is what's going to come your way. So let's go on. Let's do a 45. Tangent 45. Well, do you see this one's going to be a little easier? Aren't you going to y over x? Wait, they're the same. Exactly. What's anything over itself? 1. So for this, now I have 1 because it was square root 2 over the square root of 2. Square root of 2 over 2 over the square root of 2 over 2 is 1. So let's now look at the 60 degrees. 60 degrees isn't the same as pi over 3. So aren't we going to do square root 3 over 2 over that? Aren't we going to do y over x? So when I do square root 3 over 2 divided by 1/2, what you should notice is that's going to be square root 3 over 2 times 2 over 1. Don't those cancel? That one's a little bit easier. Square root 3. So the square root of 3 is the answer to that one. That one would be easier, but these 3 things you just got to memorize. You can calculate them every time, but if you just learn to recognize these, you don't have to do the calculations. You just get used to them, and you can find tangent very quickly. Sine, cosine, tangents are the easiest to find. The tangents, sine and cosine are the easiest to find. The tangents, you have to do a little calculation. You always have to do the y divided by the x. Y divided by x.